Hello and welcome back to another video. Here we are going to solve another past year paper from Probability and Statistics 1, and this paper is from May-June 2019 and the component is 970962. So let's start with the first question. So here's the question number 1. Two ordinary fair dice are thrown and the number obtained are noted. The event S is the sum of the numbers is even, and the event T is the sum of numbers is either less than 6 or multiple of 4 or both. So showing your working, determine whether the events S and T are independent. So we need to find if we need to show that they are independent or not. So we are going to calculate probability of S intersection with T and probability of S and probability of T. So if we can somehow prove that they are same, it means they are independent. If they are not same, it means they are not independent. So that is how we'll do this. So first of all, let's mark all the possibilities for S and the T. So for S, it is going to be the sum of the number is even, and we know that if we add two odd numbers, then only you get we get the even number, or if we add both the even number. If we add both even or both odd, then only we get the even number as the sum. So here we have the two fair dice, so we'll mark them all. For one we have the possibilities like 1 plus 1, 1 plus 3, 1 plus 5. For 2 it is 1, 2 plus 2, because 2 plus 1 is 3, 2 plus 4, and third one is 2, 6. And if first die came with 3, then the possibility for second die would be 1, 3, 5. Similarly for 4, 5 and 6. So there are 3 ways from here, 3 possibility from here, 3 from here. So these all are the possibilities. So it means n of S is 3 plus 3 plus 3, 6 times, so 3 6 are 18. And we know that if you are throwing two ordinary dice, the total number of outcome would be 6 into 6, 36. So the probability of S, event S, is going to be 18 over 36. Now we will calculate for T. T is the sum of numbers is either less than 6 or multiple of 4 or both. So we'll start with first of all less than 6, and we know that for 1 it is 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 5, 1 plus 5 would be 6, so we'll not include it. If it is 2, and then it can be 2 plus 1, 2 plus 2, 2 plus 3, 5, but 2 plus 4 will be 6, which is not possible here. And in this 3, 3, 1, 3, 2, 3, 3 is 6, so again we will not take that. For 4 it is 4, 1, and 4, 2 would be of course more than 5, so will not take that, means it should be less than 6. So this is the first possibility if it is like going to be less than 6. And for multiple of 4, the first possibility when it is 4, multiple is 4. So for 4, if 1 is coming, then the another possibility is 1 plus 3, 4, or 1 plus 3 plus 1, again it is 4, or 2 plus 2, they are 4. And the next is 4 2s are 8. For multiple of 4 it is 8 also. So for 8 it is 2 plus 6, 6 plus 2, 4 plus 4, 5 plus 3, and 3 plus 5. So that's it. And for 4 3s are 12, it is going to be only 6 and 6. So let's write all the possibilities here. 1 3 we already have, 1 and 2 2 we already have, and then 2 6 will add this 2 6, and then 3 1 is there, 3 5 is there, so we'll include 3 5, and 4 4, so 4 4 also, so this is also included, and So we are done with this, this. So we are left with 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 and 14 15 and 16. So the total number of possibility for T would be 16. That's why the probability for T is going to be 16 over 36. Now we will calculate for S intersection with T. So we will calculate in S intersection T. So let's find out how many numbers will be coming, like how many how many pair are common in these two. So we can see 1 is common. I cut it so that I can count at the last. 1 3 is common, 1 5 is not there, 2 is common, 2 4 is not there, 2 6 is common, 3 1 is common, 3 3 is not there, 3 5 is there, 4 2 is not there, 4 4 6 4 is there, 5 1 is not there, 5 3 is there, 6 2 is there, 6 6 are there. So there are going to be 1 2 3 4 5 6 7 8 9 10. So there are 10 elements in S intersection T. So it means the probability of S intersection intersection 10 over total, that is 36, which is of course not equal to 18 over 36 into 16 over 36. That's why S and T are not independent. So I hope it is clear. Let's do the second question. This is the question number 2. The volume of ink in a certain type of ink cartridge has a normal distribution with mean 30 ml and the standard deviation 1.5 ml. So if we take X as the amount of volume of ink, then it is normally distributed with mean. So it is mu is 30 and sigma square is going to be 1.5 square. So we require the two parameters, mean and variance, so which is provided. Now people in an office use a total of 8 cartridges of this ink per month. Find the expected number of the cartridges per month that contains less than 28.9 ml of this ink. So first of all, if it is expected number, we know it is going to be always the expectation of any variable, expectation of any random variable is NP, N into P. So we require this P, corresponding probability. So the probability is to get the contain this volume of ink is less than 28.9. So if we have this value, this probability, then we need to only multiply with the number of cartridges we want, and that will give us the expected number of cartridges per month we are going to use. So let's calculate first of all what is probability of X less than 28.9. In the standardized form, it is going to be probability of Z less than X, that is 28.9, minus mu, that is 30, over sigma, that is 1.5. So it is probability of Z less than, it is minus 0.1 minus 1.1 over 1.5, which is less than 0. This is equal to probability of Z is less than minus 0.733 and so on. So we only require till 3 decimal places, and if we draw the normal distribution graph, we can understand from there this is going to be mean, and if it is less than, so in the standardized form it is going to be 0. If it is less than this, so it means if it is minus 0.733 and so on here, and then we require this probability, and for that we will find the corresponding positive value, that is 0.733, and we will calculate this probability, and this is going to be 1 minus phi of positive value of this, that is 0.733, and this value from the distribution table we can get 1 minus 0.768682, which is 0.2318. So the probability is probability that the ink volume of ink in this in certain type of ink cartridge is less than 28.9 is 23.18. and so the expected number of expectation is going to be 8 into this value 0.2318, and it is 1.8544. so it is going to be expected number of cartridges per month. It is, since it is 1.85, so we can write approximately 2. So approximately we require 2. The expected number of cartridges per month required is going to be 2. I hope it is clear. Let's do the next question. Here's the third question. The probability that Janice will buy an item online in any week is 0.35, and Janice does not buy more than one item online in any week. Find the probability that in a 10-week period Janice buys at most 7 items online. So it's like the total number of trials is given and the probability of success is given. If I'm taking as X as the number of item buying online, then the success probability is 0.35, and we are going to work on the 7 items. So it is binomial with parameter 10, n is 10, and success probability that some Janice will buy the item online is 0.35. Now this thing question in the probability form, we can write probability of X at most 7 means not more than 7. So it is going to be less than 7 or equal to 7, at most 7. So it is less than or equal to 7. We are not going to calculate from 0 to 7, so we'll do it as 1 minus probability of X greater than 7, and X greater than 7, it is going to be the probability at X is equal to 8 plus probability of X is equal to 9 plus probability of X is equal to 10, and by the formula it is going to be 1 minus, and we know that if X is a binomial with NP, then probability of X is equal to R is given by NCR P raised to the power R and 1 minus P, that is Q raised to the power N minus R. So we'll use it here and we can write this whole probability as, so we will simplify these all. So this value is going to be 1 minus the whole in the bracket 10C8 into 0.35 to raised to the power 8 into 0.65 raised to the power 2. From the calculator it is coming 0.00428 till 3 significant figure, and plus 10C9 0.35 raised to the power 9 into 0.65, it is coming 0.0005123, so till here, plus this value 10C10 into 10C10 is 1, we know that it is going to be simply 0.35 raised to the power 10, because this power would be 0, I missed it, this power should be 0, and this value is coming 0.0000275, so 2758, so 279, and then we'll calculate this. The answer is coming 1 minus this total value is the sum of this all 0.0048199, so it is going to be 42, and hence 1 minus this is 0.995 5, 1 and so on. So the answer, where this answer we can write till 3 significant figure as 0.995. So this is the required probability when the in 10-week period Janice buys at most 7 items online. I hope it is clear. Let's do the second part. Second part is the probability that Janice buys at least one item online in a period of n weeks is greater than 0.99. Find the smallest possible value of n. So whenever this type of question comes, we only need to take care of the different number of trials. Now the number of trials become n and the success probability remains same because it belongs from the previous one only, 0.35. And if we write this condition, the probability that Janice buys at least one item, so it is going to be probability of x greater than or equal to 1. This probability is greater than this, so it is going to be greater than 0.99. So now we can calculate with the help of the formulas. So first one, if it is probability of x is greater than or equal to 1, so we can calculate in place of finding 1, 2, 3 so on till n, we can simply calculate 1 minus probability of x less than 1, and we know it is discrete, so it is exactly same as probability of x is equal to 0. It is 0.99, and hence if we will transfer, we will get probability of x is equal to 0 is less than 1 minus 0.1 minus 0.99, which is going to be 0.01. And we know that if it is x is equal to 0, so it is going to be nc0, that is 1. Success probability 0.35 to the power 0, that is again 1. So we are only left with 0.65 raised to the power n. So this can be written as 0.65 raised to the power n is less than 0.01. Now we need to find the value of n. We can use the log also and trial and error as well. So let's find out by the log first, and then we'll discuss the trial and error method as well. So if we take the log both the side, so it is going to be n times log, natural log 0.65 is less than ln of 0.01, and hence now we can find n, but we need to be very careful because this value is going to be less than 1, this value is less than 1, and we know that log value when it is less than 1 is always negative, so this sign will be changed. So n is going to be greater than ln times 0.01 over ln times 0.65. So this value from the calculator, of course, is going to be 0.01 whole divided by ln 0.65. So it is coming 10.69 and all. So the least possible values of value of n, which is more than 10.69, is going to be 11. So that is the least value. Otherwise, now if you want to do the same question, find the value of n by trial and error method, we'll check for different n from the calculator, and we'll only write for 3 or 4. Let's start with the 9th. So 0.65 to the power 9 is coming. For 9 I'm checking this 0.65 raised to the power n, that is 9 is value, this value is 0.0207. so we can understand that this value is still greater than this 0.01. so we'll check for n is equal to, let's say, 12. N is equal to 12, this value is coming. For n is equal to 12, it's like trial and error, so we can calculate on any random value. So I'm just calculating, skipping three numbers. So this value is coming 0.00568 and so on. So this value again, now it is going to be less than this 0.01. so we can check for n is equal to 11, and when we will check for n is equal to 11, this value is coming 0.00875 and all. So this is still less than that 0.01, but when we will put n is equal to 10, we are going to do this all by calculator, so we don't have to worry about. And this value at 10 it is 0.013 and so on, so which is of course greater than that. So the least value for that is going to be 11. So from here also we can write the value of n. I hope it is clear. Let's do the next part. Fourth question is, it is known that 20% of the male giant pandas in certain area weigh more than 121 kg and 71.9% weigh more than 102 kgs. Weights of male giant pandas in this area have a normal distribution. Find the mean and standard deviation of the weights and of male giant pandas and in this area. So we can take x as the weight of the male giant pandas. So it is going to be normally distributed, so I can write mean as mu and standard deviation as sigma, so variance is sigma square. Now we'll consider the condition. First of all we need to draw the diagram, distribution diagram, and if we draw it, it would be very much clear what we need to find. We know that this is mean. So 20% of the male giant pandas in certain area weigh more than, so 20% and more than, so it must lie somewhere here, because we know that this total area from the left side of the mean is always going to be 50%. So if we are talking about the more than this value, so it should be somewhere here on the right side of the mu. So this would be corresponding to it is going to be corresponding to 121 kg, and this is 20%, and the next one is 71.9% weigh more than 102. So it means more than 50%, so it should be lying here, so that this probability will be more than 50%, that is 71.9%. so this is going to be corresponding to 102 kg, and this total area is 71.9%. Now we can calculate this value by the standard deviation standardized form, and we can see this region corresponding to 102, we will get another value here. It can be any value, but corresponding to this value, this area towards the left hand side, it would be 71.9%. So we can write this two condition as probability of x greater than 102 is 71.9%. In the standard deviation, in the standardized form, it is going to be probability of z greater than 102 minus mu over sigma, and this is going to be 71.9%, or we can write 0.719. So now we can see it is same as, it is going to be negative value because it is lying towards the left hand side of the mu. So if it is negative, we can simply write 102 minus mu over sigma as negative of phi inverse of 0.719. And similarly for this condition, probability of x greater than 121, it is coming 20%. So probability of x less than 121, it would be 80%, and from here we can convert it into the standardized form. It is z less than 121 minus mu over sigma is equal to 0.80, or from here 121 minus mu over sigma is going to be positive phi inverse of 0.80, because once we have converted this towards the left hand side, it is going to be positive value. And so we have the two phi inverse, we can calculate from the distribution table, and we'll get the two simultaneous equation in the mu and sigma, and then hence we can find the value of mean and standard deviation. So let's calculate the find the phi inverse of these two values. This inverse of it is going to be 0.58. This is 0.58, and we'll take the negative of it because 102 is towards the left hand side of it. mu, and 0.80, phi inverse of 0.80 is 0.842. So from this equation we got 102 minus mu is equal to minus 0.58 sigma, and from this equation we got 121 minus mu is equal to 0.842 sigma. So now we'll calculate the value of mu from here. So if we'll subtract this first equation from here, we will get mu cancel, 121 minus 102, and this is going to be 19 from here, and this is equal to 0.842 sigma minus plus 0.58. This is going to be 1.422 sigma, and that's why sigma would be 19 over 1.422. So the answer become 13.36. so till 3 significant figure it is going to be 13.4 kg, because it was weight. So sigma is standard deviation is 13.4 kg, and for mu we'll replace it in any of the equation. I'll replace in the first one. It is going to be 102 minus mu is equal to minus 0.58 into 13.4, and minus 13.4 into 0.58, it is coming 7 point, so it is minus 7.74964 and all, and that's why mu would be 102 plus 7 point, this value 7.7496, and that is going to be 109.74 and all. So till 3 significant figure it is going to be 110. So mean is going to be 110 kg, and standard deviation is going to be 13.4 kg. I hope it is clear. So that's it for this video. We'll discuss the rest of the 3 questions in the next video. Till then, thank you so much.